first time in class, we have used what is known as the product rule. Because if you take the derivative of both sides, so just like always, we take the derivative of both sides. There's no rule that fits this particular situation other than the product rule. Okay? Product rule, if you look on your green sheet, is really, really simple. All you have to do is notice that we are starting with two factors. Those two factors are being multiplied, of course. That's what factor means. So we start with two multiplying factors. To apply the product rule, all you do is you write down the second factor. And you multiply the second factor by the ddx, or derivative, of the first factor, like that. Then it's plus, and you do the opposite. So now I write down the first factor, and then I write the derivative, ddx, of the second factor. That's the product rule.
Basically, you take the derivative of both and switch the...
Correct. So really simple. Second function multiplied by derivative of the first, plus first function multiplied by derivative of the second. Question? So what you start with, now look, the problem says f of x equals, the quotient rule uses an f and a g in the rule, but the f and the g in the rule are different than the f we're starting with, so don't mix them up. So the f you see here, this is a different f than the f you see in the rule. The rule right here says derivative of f times g. Can be rewritten as g multiplied by the derivative of f plus f multiplied by the derivative of g. That's the rule. So again, this f is different than over here. So I'm thinking of this as being the f in the rule, and this as being the g in the rule. So I write down the g, I multiply by derivative of the f, plus, write down the f, multiply by the derivative of the g. So because it's symmetric, it's easy to memorize. And wave if you need to do more talking. No one's waving? Cool. Like I did with the buff packet, to help you with this homework, I'm doing different examples in different classes. So in A1 today, we did a video for problem numbers 4, 14, 5, and also 9. And we'll do a few different ones in this class so we get a good collection of examples to help you with the homework. So this is just the product rule. So that's the product rule. Question? Okay. Once you apply the product rule, there's nothing new to learn. Now we just use the rules you have been using. So, and we can start doing more and more shortcuts. You've done 80 problems now, so dx over dx is 1. Plus, okay, look at this one. Everybody look up. Here's how I remember the E rule. Shortly after fall break, we will have the next test. So you do need to get the green sheet memorized. The derivative of E to whatever. The derivative of E to whatever is E to the whatever multiplied by d over dx of that same whatever. Questions today? Okay, cool. I think after 80 problems, most of you can do this in your head now. So just stare at it. Think about how you would find this derivative. Raise your hand when you know what this will, like what can this be rewritten as? Just do it in your head. Again. So what does this become, Sydney?
Wait, is it -2?
-2. I would use the addition rule first. So in my head, what I'm doing is, I'm thinking, okay, d5 over dx is going to be 0. Then here I would just use the multiplying constant rule. So pull out the 2, I'm left with dx over dx, so just like that. And that's just simply -2. So how many knew this would become -2? 2 points, 3 for Sydney. Questions? You okay? So I purposely made a notational error that I've seen a lot of students make. Hands up if you know what I wrote wrong there. Okay, everybody, what's wrong? Like, as written, I lose the point. I don't get the point this way. Julia?
Wouldn't you have to multiply the -2 instead of just subtracting?
Yeah, it looks like we're subtracting. Who knew that? 2 points, 3 for Julia. Okay, on the written portion of the AP test, you stop right there. Don't do anything else. Just stop. Okay? But on a multiple choice test, that won't be an answer. We have to factor. So I'm going to factor out the e to the 5 minus 2x. So we go f prime. Okay, remember, when you factor, it's like the reverse of multiplication. It's the reverse of distribution. So this will be multiplied by whatever is here. And we have to get this. So raise your hand, don't overthink it. What must I write here so that I go this times this becomes this? Show your hand. Chris?
1.
How many knew it? That's a common error. 2 for Chris, 1 for the rest. Don't forget the 1. Okay? Another way to think of it is, when you're factoring, you're really dividing and multiplying simultaneously. So we take this divided by this, the result is 1. But to make sure they're equal, we have to multiply this back in. So now you take all of this divided by this. All that's left is a -2 and an x. If you were to distribute, you'd get the same thing. So, questions? Please. Uh-huh. Are you okay with the 1?
Yes.
The way I like to think of factoring, Kennedy, is I identify, so I look here to have a term plus another term. The only factors in the first term are really this, and there's always a factor of 1. The other term has 3 factors, x, -2, and this. So I'm going to factor out the common factor, which means I take this divided by itself. The result is 1. This, if I were to divide, you'd have x. I don't need to write it out, I guess. So when I divide that one, all that's left is the x and the -2. 2 points. Need more help, Abby?
How do we know that we still have to divide it? Just that no, we still have to factor it, just because there's both of them on.
Really good question. 2 points for Abby. So again, on the written section, you'd stop at the orange, you're done. Don't do anything else. In the next unit, we're going to find a derivative like this, and then we're going to have to analyze the derivative. And the derivative is much more easy to analyze in factored form. So that's really why we factor. So, questions? Please.
Do you want us to factor on the homework?
In order to get the answer on the back, you'll have to factor. So, points. Anybody else? Just numbering the steps. If you'd like to ask about any step to any step, just raise your hand, please. Anyone?
Is that how you find this derivative? Some cases like f prime, you find the derivative over to take that, put it over these two x.
So, like we've said before, this is a formula for finding a big long list of xy pairs. By applying the derivative operator to both sides of the equation, we maintain equality. And we are creating a new formula which can find the tangent slope of all those xy pairs.
So when you were factoring, you have the e5 minus 2x. How do you know you use that one when you're factoring? Like, how do you know that's what you were going to like divide?
Factor out?
Yeah.
So I'll get you to see it. So in this line, we have a term plus a term. Just one factor here, really. How many factors here?
3.
Good. What are they?
X and then e5 minus 2x and then -2.
Good. So what factor is the same in both terms?
The e5 minus 2x.
Right. The common factor is what you take out.
Okay, so you find the most of it.
Yeah, the mathematical word is you take out the greatest common factor. So, there you go. Cool. Next one. Write down 19, please. All right, here we go.